Hello guys, my name is Harun and welcome to my channel. This series is a series of tutorials on scientific programming using Python. Now, this is actually the second and third workshop session that I conducted in my department, in my institute, between August 17 and 21. Because I was kind of busy with other works, I couldn't record these videos at the same time, so I'm recording them right now, and hope you guys like it. Now, this is actually session 3, wherein we are going to talk a little bit about how to do map plotting in Python, and also we'll be looking at more scientific topics. Okay, now today in this lecture we'll see how to do a map plotting in Python. Okay, now what I mean is, let's say you have a map, you have a data, then you want to plot this data on the entire world with the present continents, seas and everything. Okay, now if you want to do that kind of a job, what you need is that you need to use certain commands, and for that there are certain libraries available. Okay, and if you want to make plots on map, okay, or superimpose plots on maps and everything, okay, you need a module called as Basemap. Now how do you go about with that? Okay, now how to get that is simple. Open your terminal, and then okay, now since I assume all of you guys are following with Conda, so what I have to do is that open your terminal and type conda install basemap. Okay, just type this with the internet connection on and press enter. It will search a bit. Okay, and from in my system, it's the basemap is already installed for both version 2 and Python version 2 and Python version 3, so it just shows that all packages are up to date. But in case if you do not have it installed properly, then it will just like the previous installations which we saw for netcdf. It will just list all the dependent libraries, the libraries that has to be upgraded or downgraded, and the extra libraries that has to be installed and everything. And it just asks you for permission to proceed. If you give yes, then it will just download all the important libraries from the internet, unlink the packages, link them again, and then that's about it. And that's how it's done. So this part will be pretty easy. So what you do is that open your terminal and type conda install basemap and press enter and just follow whatever is going on. It's very simple, and then your basemap library is installed. Okay, now coming back. Okay, now if you guys want to have a full-fledged example of how to do and everything with lot more details and clarity, okay, I recommend you go to this web page, like this web page, matplotlib.org basemap/user/example. Okay, now if you go to this website, you will get a lot of libraries like this. Then you will get a web page like this. Okay, and in that web page, okay, if you see, you will have a lot of examples of how to make plots superimposed on top of maps nicely. Okay, they have a lot of examples. This is actually for an orthogonal projection. This is for let's see, what is it? Yeah, this is for a stereo projection, stereographic projection. This is for what's this for? Okay, this is for a Miller projection, and not only that, you have several other projections that are available. You can make all kinds of fancy plots like this, okay, and even plots like this. So it's not a problem. Okay, if you guys want complex examples over here, you can just come over here and have a look, and trust me, it will be good for you. It will be interesting and nice. Okay, now not only that, you can do quite some kind of crazy plots even like this on your map, but the thing is you have to write a lot of code and stuff, but it's possible. Okay, now let's get back to our example, and I'll just show you guys like how to proceed with this.
Okay, now all I have here is I just have a very big lengthy set of code, but don't be alarmed, I'll walk you guys through. Okay, open your spider. okay, and get a file script ready. And what I'm going to do in my terminal, I'm just going to check my current working directory. It's same as this. Yeah, perfect. Now let's type the magic command, matplotlib qt, so that all the plots, they do not come in the console, they come in a separate window. Fine. And now what I'm going to do is that let's import these lines. To use basemap, what you need to do is that from this mpl underscore toolkits dot basemap library, I mean, this is the module and this is actually, I guess, the class. From this you have to download this object called as basemap, okay, basemap, okay. And now import it, and then that has to be available. After that, what you have to do is that you need your regular matplotlib pyplot option, and then you need your numpy arrays for all your computation. So let me just copy all this, okay. Let me paste this up over here. Now what the reason I'm pasting it up over here is because I can paste it over here directly, okay. Oh well, let's see. Let me delete all this. Not a problem. Yeah, fine. Now what I'm going to do is, okay, I will explain you guys what to do. Okay, now ignore these for a while, and what you need is that you just need an object or a handle with which you will be drawing the map and everything. Okay, map and setting the parameters and everything. For that, what we need is that we need an object called as map, or this can be any name like m or something, that doesn't matter. Okay, it needs a value called as map, and that should be equal to basemap with a lot of arguments put inside it. Okay, now let me explain what's going on. Basemap is the mapping object available inside mpl underscore toolkits dot basemap. Okay, and what it'll do, this is going to set your basic mapping details clearly. Okay, it's going to set your mapping parameters. Now in this, there are like, as of now, there are like 1 2 3 4 5 6 parameters inside. Okay, but actually for basemap you have about, inside mpl underscore toolkits dot basemap, you have, okay, you have about so many categories, so many what do you say, so many parameters inside. Depending on which kind of projection you use, they kind of split, they kind of get importance or not. Okay, if you guys go to the website like matplotlib.basemap/api, you'll get this web page, and you can get to have a look at all these and all these. Okay, now like coming back to the example, sorry, where was that? Yeah, oh good. Now coming back to now this is the example. Now if you look at it, okay, what I'm saying is that I just want the map projection to be Miller's projection. Okay, and for the Miller map projection, I should write the projection to be equal to mill within quotes. Okay, there are like several kinds of projection available by in my basemap. Okay, and these are the several types of projections available. And if you want Miller cylindrical projection, you have to type word mill. So let's say if you want a Mercator projection, okay, for that you need to type MERC. And suppose if you want to find a Lambert azimuthal equal area projection or something like that, you have to type LAEA. Okay, like that you have like 20 or 30 different types of projections over here. Okay, you can pick any one of them as per your need. And was it? Yeah. Okay, you can write that. And then let's go to the other parameters. This is actually this actually sets the lower left corner latitude, and this actually sets the upper right corner latitude. Okay, think about this way. Let's say if you're drawing hold on, I think I'll explain this with a journal. Hold on. Okay, think about this way. Now let's say if you want to draw a map, okay, now if you want to draw a map, okay, you need first of all, for at least for a Miller's projection, it's actually a rectangular map like this. Okay, now what you'll have is that your latitudes will go up and down, okay, your longitudes, yeah, will go east and will go left and right. Okay, now so that makes us, so for that, because of that reason, okay, this is actually the top of the map, this is actually a bottom of the map, this is actually your right, this is actually your left. Okay, as per this, okay, what you need is that if you want to set the map, you need four options over here. You need to define the four corners of the map with cylindrical projection. Okay, for that we need to specify but for us we use left, right, top, bottom notations, but in the map you need latitude, longitude positions. Okay, now how is it given is that it's given in terms of latitude and longitude. Okay, now what we need is that, now what is it saying, okay, now what it's saying is that if you have, okay, now LLCR N LLCR N mean LLCR NR lat, what does it mean is that it's simple as that. LLCR NR means lower left corner. So if your lower left corner will be, your lower left corner will be this one, so this will be your LLCR NR. Okay, this will be your okay, this will be your lower left corner. Okay, and this will have two portions, a lat value and sorry, we go to x-axis notation, x and y-axis notation, so this will have a ln value and a lat value. Fine, that's about that, like that. Okay, now what you need to do is that you need to specify the longitude and latitude. Okay, so for that what I'm going to use is that I'm going to use LLCR NR lat. Okay, now what does that do is LLCR NR lat is actually sets the lower left corner latitude, so that will so this lat, okay, this lat is actually your lower left corner latitude. Okay, so that parameter that you're going to pass, LLCR NR lat, that you're going to pass will give you the lower left corner latitude. Okay, similarly this will give you your lower left corner longitude given by the keyword LLCR NR ln. So if you guys notice, this is your lower left corner longitude. Okay, and similarly, okay, if for a rectangle, if this point is fixed, okay, and if this point is fixed, and you just need one more point to define the length and breadth. Okay, and that will be you don't need this, but you need this point. Okay, and this point is actually your top right corner, okay, or else upper right corner. So this is given by the notation upper right corner, UR UR stands for upper right, CR stands for CRNR stands for corner, and this will also have a longitude value, a latitude value. So this will be your URCRNR ln. Okay, and this will be your URCRNR lat. Fine, that's about it. Now if you go by that method, okay, and that method, what we're saying is that we're giving Basemap with the projection, Miller's projection, and we're setting the map to be confined between the limits between the corner, lower left corners and the upper left corner latitude longitudes based on these four values. And then resolution, this is nothing. Like if you want the if you set set the resolution to be L, it means that the resolution will be low, so the lines will be very nicely packed. If you set to be coarse, the borders will be kind of not so proper. That's about it. It's like that's about it. Okay, So what I'm going to do is that let me copy all this. Let me copy all this and paste it over here. Okay, ready? Okay, now ready. So this map will be ready because I haven't plotted anything, so this will be just ready. Okay, and now let's come back. Okay, now what we can do is that there are now the map is ready. The setting is ready. Now if you want to draw coastlines, countries, states and states or full continents, there are options available. Okay, now map.draw coastlines will give you the coastline of the continents. So what I'm going to do is that if I just type map.draw coastlines with a line width of 1 pixel by press enter, there you have it. You have a Mercator projection, sorry, a Miller's projection, okay, with all the continents and continents drawn nicely with the coastlines. Okay, now let this be as it is. Okay, let me not close this. Let this be as it is. Okay, let this be as it is. Okay, now what I'm going to do with this line, map.draw countries. Okay, what does this will do is that it's going to plot all the borders of all the countries. Now if you see, you just have only the continents here. Now if I draw this, check this out. Okay, now if you guys notice, you have a lot of borders over here indicating that these are the countries. It just now it's marked all the country borders of all the countries available in the world precisely. Okay, now that's good. As of now, so far so good, right? Now watch. Now not only that, you have, okay, let this be there. You have features to fill the continents and everything. Fill the continents with colors and lake with aqua and everything. You can do that. Okay, now if you do as of now, I'm not going to do this, but if you do this line, fill continents with color coral and lake underscore color to be aqua, is going to fill all the continents with coral color and all the lakes and water bodies with an aqua color. So coral will be like somewhat orange, and aqua will be like somewhat like magenta color. So you'll get you'll get a color. The map will look like this. The coloring pattern will look like this. Okay, so I'm not going to do that because I'm going to superimpose a plot on top of it, so I'm not going to do that. But anyway, you can try anyway. And then this is another option available. Like if you want to draw the states of all the countries, okay, this again is possible. So what happens is that if I draw this, okay, now look at the map. Okay, now all these countries do not have state divisions marked on them. Okay, it's just only the country borders have been marked. Okay, now if I press enter over here, check this out, check the map out. See, your United States, Brazil, Argentina, and many of the countries in South America, some countries in Australia, all of them have been marked with the states. Even Canada has it, but possibly because for other countries like China and everything, I'm not sure, I don't know why, but maybe the state markings are not available, I suppose. That's all I can think of. Okay, for some countries the state markings are available quite nicely, so it just puts the state borders nicely and everything. Okay, that's about it. And this will be helpful, this could be helpful if you're going to go for a very short or a very narrow map or something. Okay, next what we can do is that we can draw the map boundaries using this line. Now what this will do is that it is going to draw the map boundaries a little harder. Okay, if you look at it, now if you see this line over here, this black line over here, initially it was not present. How it came? It because of this map boundaries. Now with that, we have the entire map is surrounded by a box. Okay, surrounded by a box as it is. Okay, and next, not only that, there are other features that are available as well. So now let's go to it. Now if you look at the map is plain, drawn, everything. Now we want it to be nice if you just have some grids and boxes filled over here. It's possible, that is available. For that, what you need to do is that you need this you need to draw the meridian lines and parallel lines. Okay, now map dot draw meridians. Okay, what does it do is that it's going to draw your parallel vertical lines in the map. Okay, vertical lines in the map, and this value, what it says is that see, it's going to return an array which starts with which has a maximum value of a minimum value of minus 180 and a maximum value of 180, and each of the values will be separated by 30 units. So you'll have something like minus 180, minus 150, minus 120, so on and so forth up till 180, but it won't cover 180, just one unit below, like that. Okay, so you're going to have a lot of lines, and those lines will be marked vertically. Similarly, draw parallels will draw horizontal lines to draw your latitudes. This will mark your longitudes, this will mark your latitudes. Okay, and then labels command over here, what does this do is that it's going to mark the labels on your x and y axis, so there's a notation for it. Now the notation that is actually given, what does label take? It takes a list of 4 values, all of them between 0 and 1, and this is how it goes. Now the first value is for left, second is for right, third is for top, and fourth is for bottom. Okay, now if the notation is 1, let's say, in any one of these values, okay, one of these values, the labels will be written over there. So if I set draw meridians and I set 0010 over here, then the longitude labels will be printed on the top. Now if I put 0001 over here, instead of this 0, if I put it to be 1, all the longitude labels will be on the bottom. Okay, similarly for drawing the similarly, if I set 0 here, instead of 0 if I set 1 over here, the longitude, the labels of the latitudes will be written on the left. By setting 1 here, it will set all of those values to be on the right. Okay, now check this out. If I were to copy this and copy this, okay, let this be over, where is that? Yeah, paste it up. Okay, check the map before doing it. Okay, this is how the map looks like. Now if I press enter, it's going to plot a lot of lines over here, okay. I'm going to check the map out. There, perfect. If you see, now you have vertical lines present indicating grid lines. Fine, that's about draw meridians. Similarly, and if you notice, in the command I gave, okay, I told the labels to be on the top by using one over here, and that is what has happened over here. The labels are on the top. Okay, so this is left, right, top, bottom. So that's how it goes. That's how the methodology goes. So fine. Now next, what we'll do is that let's draw parallel lines. Okay, let's draw parallel lines. So for that, I'm using this command, map.draw parallels, and this is same as above, and this is set the labels properly. And if I press enter, it's going to put a lot of lines over here. Doesn't matter, I'm going to put a lot of lines over here. And if you look at the figure, there you have it. Your vertical lines are all available. Sorry, your horizontal lines are available. So, and if you notice, I just set the labels to be on the right using this to be 1, and that's how we have it. Your latitudes are on the right. Simple enough. Okay, that's about that. Now, as of now, so far so good. Let's do some real plotting. Well, now I have made the map ready. Now let me plot it. Okay, for which what I do is that I just create a latitude longitude variable. Okay, using numpy. Okay, using numpy. Okay, Now R1, R2, L1, L2 actually that denotes the denotes the left, right, top, bottom limits of latitude and longitude and all. L1, L2 denote the left and right longitude limits. R1 and R2 denote the bottom and top latitude limits. Okay, latitude limits. I'll tell about what the centering mean and what the centering mean and everything in a minute. Okay, now watch this up. Check this out. Okay, now I've set them. I set the lats and I've set n lats to be 73 and n lats to be 145, meaning I'm just going to create that many number of points using these commands. So if I copy all this and paste it over here, look at my variable explorer. Okay, now your latitude will have 73 values from minus 90 to plus 90, and then your longitude will have 145 values from minus 190 to plus 190 minus 180 to plus 180. Fine. Okay, that's what we did over here. And then what we need is that we need a grid. Okay, to plot we need a contour plot. So especially for this we need a contour plot. So what we need is that we need a grid. So for that, what I'm going to do is that I'm going to use the NumPy mesh grid option to create grids. If you guys remember how grids are being made, if you don't know, if you guys know how the grids are being made, you'll understand what's going on. If you don't follow, don't worry. In one of my previous tutorials, I've explained this for making the plot a little fancy and everything, so that at least in the interpolation part and all, I've explained it clearly. So if you don't understand, you can go there and check it out. You'll understand. Okay. Now what this will do is that the lons and lats will be taken as 1D arrays, and it's going to turn 2D arrays with all the x and y coordinates. All the lat long coordinates nicely made. It's going to give you a return a 2D grids. Okay, and what I'm going to do is that if I paste this up and press enter, okay, now watch, your lat will have 73 points in the y-axis and 145 points in the x-axis. Okay, that's about lat. And your lon will have your lon will have similarly. If you superimpose lat and lon, okay, you'll get the grid point. You'll get 73 cross 145 points with the distinct latitude and longitude coordinates. Okay, so this will be like a graph sheet kind of a thing. This will be like a 2D graph sheet. Okay, now okay, I need done that, but okay, now I made the grid. Okay, now what I'm going to do is that ignore this for a while. I can just have my a dummy data to plot or some data to plot. What I did is that I did nothing. I just created my own dummy data. Just taking the square of the longitude and square of the latitude, and that's it. I'm using that as my data. But if you guys want, if you have a actual realistic data, you can use that as well. So not a problem. This is just a dummy data. Doesn't matter. Okay. Now what I can do is that I can just have my data and use plt.contour to plot it. But this won't work. Reason is because, okay, we are making a map. Okay, so since we're drawing a map, okay, this map is kind of little different when compared to how how contour maps are being done. This is kind of slightly different from that. What you need is that if you want to create points and plot it, okay, your coordinates should be derived from your map. You should derive from your map object or a map class. What I mean is, if we use lon and lat directly, lon and lat are NumPy arrays. They are NumPy objects. Okay, NumPy arrays, NumPy objects, whatever you call it. If you use that in plot contour f, then the plotting will not superimpose because the ranges will not be consolidated. Okay. The reason is lon and lat are in just have latitude values. Okay, z is also in latitude values, but what happens is in the map in the map the distance is not marked in latitudes or longitudes. They actually are marked in meters. So what you need is that you need